Hi, this video is about determining whether a relationship between a set of numbers is proportional or non-proportional. So in an earlier video, we talked about the difference between linear and nonlinear. It's similar, but not quite the same. All right, it says in example A, Jamie earns $4 an hour babysitting. Complete the table and graph. All right, so if she babysits for 1 hour, she's gonna earn $4. If she babysits 2 hours, 2 times 4 would be 8. 3 hours, 3 times 4 is 12. 4 hours, 4 times 4 is 16. So if we go ahead and put that on our graph, this is our x and this is our y here. So the time is 1, the amount is 4, that would be here. The time is 2 and 8, 3 and 12, and 4 and 16. Oops. All right, so if we go ahead and connect our points, we can see that this is making a straight line. So is this a linear equation? Well, yes, and why is that? Because it graphs as a line, but remember the other way to tell if an equation is linear, besides just graphing, is to check for that rate of change. So we know that from here to here was 1 and 1 and 1. From here to here is 4 and 4 and 4. Okay, so since they're both the same, that's what we call that constant rate of change, then this is linear. All right, so then it says to write an equation that can be used to find the amount. All right, so in the last stop, we were talking about graphing from an equation. So now let's see if we can come up with our own equation. So we want to know how to get the amount based on the number of hours, right? So to get this amount, we had to do something here. So I'm going to say, let's see, what do we want to call it? We'll call it A for amount is going to equal to what? Well, you take this number and you multiply it by 4 to get this number, right? If I take this number and I multiply by 4, I get this number. This times 4. Okay, so the 4 is what was always the same. So I need to do 4 times whatever that number is here, all right? And since I don't want to put a number there, I'm going to put the variable there, which is h. So A equals 4 times h, or I don't have to write it with the dot. Oops, I can also write it as just 4h, either one, okay? All right, so it says recall that two quantities are proportional. Think way back, because it's been a while since we looked at proportional. That two quantities are proportional if they have a constant ratio, so that's a little different wording, but it's a constant ratio or a unit rate, right? So that would mean like we said that 1/2 and 2/4 were proportional because they have the same unit rate. If I simplify this, okay, then I'm going to get the same thing. So they have a constant ratio. Or if the unit rate, if this is supposed to actually be a 1 on bottom, I could divide 1/2 by 2, or 1 by 2 and get 0.5, right? And 2 over 4 is going to also be 0.5, so they're going to have the same unit rate. All right, so that's what it means to be proportional. So is this graph proportional? That's the question we're trying to figure out. All right, so when we go back and we look at these quantities, this 1/4, the 2/8, the 3/12, are those proportional? Are those equivalent? Do they have constant ratios? All right, so is 1/4 the same thing as 2/8? Okay, if I divide by 2, I get 1. If I divide by 2, I get 4. So yeah. Is that the same thing as 3/12? Well, if I divide by 3, I get 1. If I divide by 3, I get 4. So that one's good. What about 4/16? If I simplify this, if I divide by 4, 4 divided by 4 is 1. 16 divided by 4 is what? 4. Then I'm right back where I started. So yes, this graph is also proportional because these are equivalent, or they have a constant ratio. All right, so when linear equations have a constant, or linear equations have a constant rate of change. This is what we learned earlier. Okay, so this is what it means to be linear. To be proportional, you have to have a constant rate of change, and they have to have a constant ratio. Okay, so this part has to be the same. Okay, that's the part that makes it linear. But then this part also has to be the same to make it proportional. Now, there's an easy way to do this. So let's look at how it works. All right, example B, Games Inc. charges $2 per game to rent a video game plus a $2 rental charge. Complete the table and graph. All right, so again, we're starting with a graph. And they don't give us an equation, so we kind of have to figure out what to do. If he rents one game, that's going to be $2, right? So 2 times 1 is 2. But then I still have to pay the rental charge. So plus 2 would be 4. Okay, if I rent 2 games, then I have to do 2 times 2, which is 4, but still be charged the rental. All right, so that would be 6. If I have to do 3 games, 3 times 2 is 6, plus the rental charge is 8. And the last one, 4 times 2 would be 8, plus the rental charge, which is 10. Okay, so if I go ahead and graph these points, I'm going to go over to 1, up to 4, 2 and 6, 3 and 8, 4 and 10. All right, so I want to know, is the graph linear? Well, if I just draw my line, this definitely looks linear. It's making a line, yes. Okay, and if I go back and check, I can see that this is 1, this is 1, this is 1. The difference between here, so 6 minus 4 is 2, 6 and 8 is 2, 8 and 2 is 10. So definitely linear. It's a constant rate of change. Okay, but I want to know if it's proportional. So proportional compares not this part, but this part from here to here. So if I do 1/4 and I do 2 over 6, I want to know, is that ratio the same? Well, if I divide 2 by 2, I get 1. If I divide 6 by 2, I get 3. So are these the same? Nope, these are not the same. It's not a constant ratio. So then this is not proportional, right? This is what makes it linear. This part is what makes it proportional. Okay, so if I look at the difference between the graphs of example A and B, this is what I told you. There's a really easy way to figure this out. You don't always have to do this part. If I go back and I look at the graph I had earlier, right? So I have this graph here and I have this graph here. If I want to compare the 2 graphs, they're both a straight line, okay? But what I see that's different about this one is this one, like with this one is starting, it's starting at 0 at the origin, whereas this one started at 2. Well, why did that happen? All right, well, here I'm just being paid for babysitting. If I don't babysit, I get nothing, $0. Here, right, that extra $2 rental fee, okay, I'm not just paying for the games, I'm paying for something else. I'm being charged for the rental. Then that starts at 2, all right? And so this is what made this not proportional, okay? So what you need to take away from this is that the difference is that the equation or the graph didn't start at 0, and that's your clue for knowing if something's proportional or not. To determine if the graph is proportional, right? So not linear, proportional. It must form a straight line. That part's the same, just like linear. But for proportional, okay, it also has to pass through the origin, okay, which just is 0, 0. All right, so 2 things, a straight line and it goes through the origin. Okay, so let's keep going. The cost of a 3D movie ticket is $12 for 1 ticket, $24 for 2 tickets, and $36 for 3 tickets. Determine whether the cost is proportional to the number of tickets by using a graph. All right, so if this is hard for you to just put on a graph, you can make your table. All right, so the tickets, I'm starting with tickets, and then I have cost here. So I could use X and Y, I could use T and C, something like that. But 1 ticket is $12. 2 tickets is $24. 3 tickets is $36. All right, so to graph these points, 1 and 12, 2 and 24, 3 and 36. All right, so this is definitely forming a straight line. Would it go to 0 is the question. Well, yeah, no tickets is $0. So if it's a straight line and it goes through 0, this part right here, then we can say this is linear and proportional. Okay. Number 2, which batting cage represents a proportional relationship between the number of pitches thrown and the cost? All right, so we're looking for proportional, right? These are both lines. This is definitely linear. This is definitely linear. But if it's proportional, then it also has to go through where? The origin, right? So it's this one here that's proportional. So we would say Fun City. Oops, sorry, Center, Fun Center. Is the one that's proportional. And why is that? It's a straight line through the origin. Okay. All right. And number 3, the number of game levels passed by 2 friends playing video games are shown on the graph. Whose graph shows a proportional relationship? Okay, so again, we're looking to see if they're linear and they go through the origin. Now, they both go through the origin, okay, but only one of them is linear. Which one? Well, this one kind of starts linear, but then there's this big jump. So this is not linear. This is my line, has to be a straight line through the origin. So Morgan is proportional. Why is that? Straight line through the origin. All right. So again, what you're looking at today, you're going to be looking at some graphs or having to graph some things possibly. And you want to just be able to determine if they're proportional or not. So you're looking for a straight line through the origin. All right, see you soon.